Hi, and welcome back to the extra segment of the Keith Bryant Show. Originally, we had the 2 days planned, and I've said my goodbyes, but we have a very special guest with us today, Dave Hillman from Rockwell Collins. It's actually St. David's Day as well, so we have maybe extra reasons for chatting to him, but I've been wanting to interview this guy for a long time. And actually to be sitting across the table from him for the first time, it's kind of exciting for me. And Dave, something exciting's already happened to you this week, so maybe you can start by outlining that for us.
Yeah, Keith. Wednesday or Tuesday was a very special day. I was nominated and was named a Raymond E. Pritchard Hall of Fame Award recipient by the IPC. So very august group. I'm still in shock. Very humbled. Pretty special thing.
And you actually got it while you were still alive, huh?
I did. They look at that list, and it's always the graybeards up there, and sometimes those are gone after we acknowledge their accomplishments. And apparently they believe I've done something deserving to be up with that group. So very honored.
Well, for IPC conferences for many, many years, and I know obviously I've worked with you for what is now SMTA Europe, which was the Smart Group also for many years with your number two and your wingman. So you do put a lot into this industry, and we have to thank not only you but Rockwell Collins for letting you do this, because you've put a lot of key papers out for a lot of years. I was going to look and see when you first came to an IPC gig, but maybe you can say that if you're not embarrassed.
1988 was the first time I attended an IPC meeting. So yeah, I've been around for my entire career at Rockwell Collins. So as I told a few people, I'm the last of the dinosaurs. I've spent my entire career in the same group, in the same position at Rockwell Collins. So Rockwell's always supported us going to SMTA to IPC. Because when we support the committees, we support the work that's out there. If the industry gets better, we're able to get better. So we've always had that support, and we're very grateful for it.
Yeah, and I know another thing that is one of your standard jokes is I get to do all the presenting, but I have all these interns that do all the work. And again, that's also an education program.
It is. Doug Pauls and I have been privileged. So over the last 30 years, we've had at least 125 amazing young men and women. And what our running joke is, they come to work that first day. They're drinking out of a fire hose. They're completely baffled that they have to, can you have a conversation in acronyms and abbreviations and never a whole word? And we can do that. They endure endless old guy stories because Doug Pauls and I, we have a few. And if we really want to drive them crazy, you start with things like, can you tell me who Bullwinkle and Rocky are? Or who's Professor Peabody? And they, of course, pull out Google and start to work at it. But I think at the end of their first day, they believe they've been sentenced to the insane asylum. But those kids are great. I would not be where I am in my career without their efforts. They young, unpoisoned minds. It's just amazing. And the best thing is many of those kids are now engineers in our industry and doing equally great things. Yeah,
it's one of the few things, and as I say, you guys at Rockwell are one of the people that you really do have a very, very strong intern program that's been there for a very long time, and I hope not only does it benefit the industry, but it gives something back to Rockwell Collins too.
It does. We get to hire some of those kids in, and we just look at ourselves as part of a larger group where the SMTA's efforts to bring in that next generation. IPC is now working with their emerging engineering program. It's been recognized, we are graybeards. We're going to retire one way or the other, and we need to get that influence of the younger generation to take our places and figure out what the challenges and opportunities are and take our industry forward.
Yeah, future-proofing is a great thing. So what sort of stuff are you working on now in terms of failure analysis? What's the hot stuff that you're seeing that at least you can talk about?
The big things I think aren't any different than a lot of the other companies. QFN and voiding. There's a large industry question on, does the void under that center pad on a QFN, does it really matter? Because they're seeing a lot of failures. And what's interesting is that discussion probably for the first time breaks into a design discussion. Is there a functional need for that part versus the solder we put down? Or is there a solder integrity? Do we need it for the assembly side? And there are not a lot of parts that we've ever done that before. Usually if the joint's broke, the joint's broke. But I can make a perfectly good solder joint on an LED, and if I have too big a void underneath it, it'll burn up. And that's a new twist. I think it caught us off guard as an industry. And of course, there's tin whiskers. We're always looking at the PERM committee is opening up the -2 specification. Going to go back in, what have we learned in the last 5 years? What new information can mean we can be, do we need to be more conservative, or can we, be a little looser with the guidelines and the criteria to help people? Because criteria cost money. Well, as you know, when we put a specification requirement into the J Standard 001 or any of the specifications, that costs money to the industry, and we want to do that wisely.
Yeah, that's always a good thing. And I was actually talking to Mike Bix from Kaizen. The question that I asked him was about contamination testing, and are we in a situation where whole board testing is still a valid test and concept? Or should we be doing spot testing on the key areas like the QFNs and all the low standoff components and all the places that are hard to clean and hard to get the flux to completely become inert?
Well, that velocity of technology, which is the theme here for the IPC, I mean, that I think has caught us off guard because, like you said, we used to be able, I could test a whole board, and that gave me a pretty good idea what was going on. But with an 0201 in that small space, is that an issue? I love what Dr. Bixman's done with low standoff parts. He's found a lot of things where cleaning makes it worse, where we believed, hey, this is what we should do. Maybe it's opposite. Maybe we need to be rethinking out of that box and doing something different. And it's moving so fast. Now they're talking about 01, 005s, or we call them 010 halves. I can't see the 0201s. I don't know what we're going to do with the 010 halves. That's just crazy.
Yeah, magnifying glasses is the solution, right?
I think we'll let the co-ops and the younger generation look at them, because even with my reading glasses, they seem to be difficult to find.
Yeah, I was also chatting to Brooke Sandy from Indium about this whole, we kind of, I think as an industry, I won't say panic, but there was a bit of a knee-jerk reaction when we saw tin whiskers, and it was, the boards have got to be clean. So then water-soluble suddenly became the flavor of the month. And now we're saying, okay, well, how clean is clean? And is it clean over a whole area, or is it just a part of the area? Can we clean the difficult bits that cause us the problem, or definition of the hardest ones to clean? Yep. So, should we now be going back to a no clean situation, but something that's completely inert after it's been assembled?
And I think I look back a lot of the work you and I have done together with X-ray. When the X-ray first hit, we introduced that with not thinking about what might happen, and all of a sudden, I see something different. Well, is that bad? We should go do this. And yeah, that initial reaction sometimes is, well, could we take a step back, maybe think about it a little bit? And I think we're getting our hands around X-ray. But yeah, that cleaning highlights the same kind of thing. Whoa, what did we do? And maybe we should slow down just a little bit.
Yeah, my favorite X-ray thing, and it's really good. You install a system into a customer for the first time, and you're doing the training, and the quality manager looks over somebody's shoulder and he goes, "Oh my God, we've just got voids."
Well, and it's even better because they look at a through-hole component, which we've had, through-holes around before I joined the industry, and they'll be here long after I leave. And it's like, well, there's solder in all those holes, aren't there? Well, look in the X-ray and let's show you something maybe you don't want to see. And I think the unknown is always scary. The unknown bothers everyone. And what's interesting is we have these neat scientific tools now. Let's go in and understand it before we brand it one way or the other. And I know the work I did with you on X-ray went greatly to taking, all of us as technicians and saying, hey, this tool shows us everything. We still have to be engineers. We still have to understand, is it bad or is it just different?
Exactly right. And that's the comment that I make to the panic-stricken quality managers. Yeah, you had the same thing yesterday. The only difference is now you can see it, and if you can see it, you can find out, first of all, you can measure it, then you can see if it's changing, and then you can find a way of trying to improve it. So, that's for me the great thing for the last few years is we're getting better and better tools.
And I think we've added that, lead-free is no longer the hot topic. Lead-free started back in 2005, 2006. It's 2018. We have over 10 years of use by a good chunk of the industry. There's been issues. We're engineers. We tackle those problems. But it hasn't been that huge, oh my goodness, now what are we going to do? We've tackled it with that methodology you described. And, the industries that have to worry that are flight critical or safety critical or mission critical, they'll always be followers, but they can learn from the lessons if we do our work right on some of the other less dangerous or less safety critical type of things. And we'll get there. It just takes time. That's what that next generation of engineers needs to do for us.
Yeah, and it becomes a wider platform, because I can remember talking to somebody in '92 who told me that through-hole was dead, and 2 years later that you'd never see a through-hole component ever again.
My first year at Rockwell Collins, I got a tour of the floor because I had been at General Dynamics, so it's structural materials, space materials. So I didn't know the electronics industry. So I said, you need to introduce me to the process. I need to see what the pieces are. We walk up to the wave solder machine, and they said, well, we won't spend much time with this. Why? Well, it's going away in a couple of years. You don't have to know about it. And, that was 1988, and we put a new one in a few years back. They use the technology that makes the sense. It's the cost, the right reliability, and yeah, it's funny how those predictors of, this will go away, we'll never see it again.
Yeah, I mean, the big, maybe the negative for that is that, I guess in our industry now we're driven so much by the guys who buy huge volumes of components, and they're worried about height, they're worried about real estate space, and they're worried about maximum number of interconnects over a small space. And this is really, for me, the thing that's really changed our industry, because these guys are making so many components, companies are buying so many components, that what I would call the old standards have just disappeared, and the package size is reduced dramatically. They've become QFNs, they've become heat sensitive in terms of running time and all of this stuff, and it's really moving faster and faster.
Well, it's one of those rules of opposing forces, because we as consumers, we like our electronics. I never thought I'd like a cell phone, but now I can get a hold of my kids anytime I want, wherever I am on the planet. It's not an issue. They said here at the conference that pretty soon, within the next couple of years, the value of the electronics in an automobile will be worth more than the automobile itself. And that's a shocking figure when you think back when we bought cars and I had to roll the windows down by hand, I had to lock it by hand. Now we rely on all our electronics for the sensors, for the safety. So those changes are like, wow, we've got to keep up with this, and yet, implement it in a conscious manner.
Yeah, it becomes more challenging for the engineers that are out there, but as you say, thankfully there are some new ones coming along that can pick up the baton and run with it probably faster than we can run with it now.
Well, and they take, as we say, they're unpoisoned minds. They don't have these scars of past wars, and they can look at a problem and say, okay, a fresh approach. Doug Pauls and I also we are part of Rockwell College STEM, science and education work. And as Doug says, you've never lived until you've explained physics to a 3-year-old. So, talking to the kindergartners and having them understand this is a cool thing. 20 years from now, you ought to be an engineer. So getting that next generation fired up about science and math. And yeah, it's hard, but it's rewarding. It's been a great industry. We get to do great things for society, and it's just a matter of we need to keep filling those slots.
Okay. Last question, and the toughest one. You've been around, as you've intimated already, a long time. What's been the most fun?
The most fun is the mentoring. I'm an engineer. I love puzzles. We become engineers to solve puzzles, whether it's why did this board fail, or why is this part blue today and it was green yesterday? Why can't I get the wave solder machine to run? But I think the best part is we have an active mentoring program with our co-ops, bringing them in, watching their minds turn. They don't always get the right answer. They look at it, though, and just, you get out of the way. You let them go to it. And the solutions we've had and the work we've put together, you've seen from the papers. We have really high-quality papers because we've got great kids working hard on stuff. So I think just the interaction with the younger generation, helping them get ready for that next, whether it's working for us, working for another company, even going to a different industry. We know they've got a good solid base and they're going to do good things in their career. So that's been the most fun.
Well, thank you very much for sparing some time to come and talk to us. Big congratulations on becoming a Hall of Famer. It's very, very deserved. I think everybody in the industry would join me in saying that, the work that you and also Doug have done for a lot of years has helped a lot of people, and your humor and general good nature has brought a a lot of smiles to a lot of people at a lot of conferences. So thank you very much for sharing the time with us, and big congratulations, and it's been nice to be able to talk to you.
Thank you.